Well, hello everybody and welcome back to Drawing to Learn Anatomy with Khoa. If you want to know how to draw out the bile duct system and pancreatic ductal system like in this image, then please stick around to the end of this video. Well, hello everybody and welcome back to Drawing to Learn Anatomy with Khoa. My name is Khoa, lecturer of anatomy, physiology, and medical terminology, and today we will be drawing out and looking at the bile duct system and the pancreatic duct system. Okay, now for the bile ducts that we are going to draw out today, they are going to be extrahepatic bile ducts, which means that they are going to be the ductal system that transport bile from the liver ever downwards, inferiorly, until the bile gets to the duodenum. All right, okay, so now before we begin, the three disclaimers like we had before. Okay, first off, we are going to actually need three different pens for this exercise. Number one pen is going to be a black pen. This black pen is all about the structures, okay? It will be used to draw out, for example, the liver, the pancreas, and the duodenum. So this black pen is all about structures. All right, so the next one is going to be a green pen. This green pen is going to be used to draw out the structures of the bile duct system, okay? So that's going to be bile. Okay, and finally, there will be a blue pen, and the blue pen is going to be used to draw out the pancreatic ducts. Pancreatic ducts. All right, so that's disclaimer number one. Disclaimer number two, we are going to try and draw this out with a very, very reasonable pace so that everybody will be able to follow me in this exercise. But should you find out that this video is moving way too fast and you haven't got a chance to catch up, please push that pause button on YouTube, catch up with me, and then we can continue. All right, next up, number three, anatomical variation is very, very much a thing, okay? Everybody is going to be a little bit different for each other. Especially in this video, you will find that in a large portion of the population, the end points where the common bile duct and the main pancreatic duct joins together, it's not going to be the same, okay, as the image that we are going to draw out in this video. And that is completely normal, and that is anatomical variation, okay? And that's something that we have to live with, basically. All right, now that we have all these three disclaimers out of the way, let's draw out some structures. So first off, the thing that we're going to first draw out is the liver. Just like before, we are going to use a triangle to draw out the liver, like this, with three sides like that. And the reason why this is important is because the liver is the organ that actually produces bile. You will hear there's an organ that is named the gallbladder, but this gallbladder doesn't secrete bile. It actually just stores it, and then it releases it when there is a need to transport that bile into the duodenum so that it can aid digestion, okay? So liver is where bile is produced, okay? So now, let's go on and draw the next organ, and that organ is going to be the duodenum. The duodenum, just like we have said before, consists of two C-shaped curves, okay, like that, okay? It begins with the superior part of the duodenum up here. Then we will go on to the descending part of the duodenum, then the inferior part of the duodenum, and we will extend this all the way until you get to the duodenojejunal flexure that is right here, okay? After it passed through the ascending part, which is that last arrow there inferiorly, okay? So that's the duodenum. Now, attached very tightly to the descending part of the duodenum is going to be the pancreas, and the pancreas looks like this, okay? It's going to have a head, an uncinate process here, a neck here, a body here, and we will extend that body so that it becomes the tail of the pancreas. Okay, so it's going to be like that, and the tail of the pancreas is going to go all the way and it contact basically the splenic hilum. But we are not going to draw the spleen today. We're just going to draw the pancreas like that. Okay, let's delete all of this stuff. Okay, and let's just try to make this a little bit tidier. There we go. All right, so now those are the three organs that we'll have to draw out: the liver, the duodenum, and the pancreas. Okay, so now, next up, we are going to draw out the structures of the bile duct system. So please switch over to the green pen now. All right, So the first couple of structures that we are going to draw out are going to be these two ducts that come out of the liver. Bile is going to be secreted from the liver, okay? And it's going to be secreted from hepatocytes, which are very, very small cells inside the liver. And associated with the hepatocytes, we have a system of ducts called bile canaliculi. And those bile canaliculi is going to get the bile from the hepatocytes and transport them into larger and larger and larger ducts until they coalesce into these two ducts here. Okay, this duct right here, coming from the right side of the liver, is called the right hepatic duct. Okay, and this one coming from the left side of the liver is the left hepatic duct. Okay, so now the right and the left hepatic duct are going to join together. Okay, join together right here in order to make this duct right there, which is the common hepatic duct. Okay, common hepatic duct. And then the common hepatic duct is going to join up with another duct right here. Okay, before it goes behind like this of the duodenum and pancreas. Okay, that duct right here is going to extend all the way to this structure that is underside of the liver. And that would be the gallbladder right there. Okay. So that duct that leads into the gallbladder is called the cystic duct. Okay. Cystic gallbladder. Okay. Cystic duct. And then it is connected to the gallbladder. Okay, the gallbladder. All right. And then the cystic duct and the common hepatic duct is going to join together to make this duct right here that goes down like that. And that duct there is going to be running behind the duodenum and the pancreas. And you call that duct the common bile duct. Or just bile duct. Okay. So the common bile duct is going to be combining the cystic duct and the common hepatic duct juices, bile, to transport it over to this part here of the duodenum. Okay. But that's not the end of the story, because now we are going to switch over to the blue pen in order to draw out the pancreatic ducts. Okay, so the pancreas is both an endocrine and an exocrine organ. In endocrine, the pancreas will secrete hormones such as insulin, glucagon, and somatostatin. But the more important part, arguably, of the pancreas is actually its exocrine portion, because this is the portion that accounts for more than 90% of the parenchyma of the pancreas. And all of the things of exocrine that is going to be produced by the pancreas will include the digestive enzymes that will help us digest fat, carbohydrates, and proteins. And all of those enzymes are going to come from different parts of the pancreas and will coalesce into these ducts that eventually come to form a major duct here. Okay, that is going to run like this down. Okay, and that duct there, as you can see, is going to be called the main pancreatic duct. Okay, main pancreatic duct. Also called the main pancreatic duct of Wursung. Okay, now the main pancreatic duct of Wursung usually will join at the terminal part of it, is going to join with the common bile duct to form an ampulla right there. Okay, so that ampulla, that part which is common for the common bile duct and the main pancreatic duct, is called the hepatopancreatic ampulla, and also called the ampulla of Vater. Okay, now the ampulla of Vater will collect both the bile coming from the common bile duct and the pancreatic juices that come from the pancreatic duct, and it will empty into the duodenum right here. And at that point, okay, you call that place where this ampulla of Vater empties into the duodenum, you call that the greater or major duodenal papilla. All right, and around and surrounding that papilla, there's going to be a muscle, okay, a smooth muscle. And that smooth muscle is called the sphincter of Oddi. Okay, so what does this sphincter do? This sphincter is going to constrict when you are not eating. Okay, and that constriction will force the bile to go back up into the gallbladder so that it can be stored. When you eat something in, okay, the food is going to go first down your esophagus and then go to your stomach. When your stomach has decided that it's almost ready to get the food over to your duodenum so that it can be further digested, the sphincter of Oddi will open. And that opening of the sphincter of Oddi will release the bile and pancreatic juice into the duodenum, okay, so that these fluids can help digest the substances that is within the food, like for example, the carbohydrates, the proteins, and especially fat, okay? So now, let us see that process in motion. So first off, what is going to happen is that the liver is going to produce bile. And that bile is going to run down these two hepatic ducts, okay? And those two hepatic ducts will lead the bile into the common hepatic duct, and it will go down, okay, the common bile ducts and get down to the ampulla vatae, ready to be discharged out into the duodenum. But at that point in time, we have not eaten yet, okay? So the sphincter of Oddi is not open. So now what's going to happen? The thing that's going to happen now is that bile is going to reflux back like this, okay? It's going to reflux back up here into the cystic duct, and the cystic duct is going to lead the bile over to be stored at the gallbladder, okay? So that is going to be what happened when we're not eating. But as soon as we eat, okay, the food is going down to the stomach. And when that happens, the sphincter of Oddi is going to open. And so when the sphincter of Oddi is open, then the bile is going to come from the gallbladder over to the cystic duct, over to the common bile duct, and going to the ampulla vatae, where it will go into the duodenum right there at the greater or major duodenal papilla in order to help us digest things, okay? And the bile is going to help us greatly in emulsifying the fat that will then be digested, okay? So very important fat digestion. So now, pancreatic juices is going to flow out primarily through the main pancreatic duct of Hua-sung. But there is an alternative pathway for the pancreatic juices to go out into the duodenum. And that is via this duct right here, okay? That branches out basically from the main pancreatic duct. And that duct there is called the accessory pancreatic duct of Santorini. And it offers an alternate way for pancreatic juices to come out into the duodenum. Now, if the main pancreatic duct is blocked by some unknown reason, then pancreatic juices can still flow into the accessory pancreatic duct in order to empty into the duodenum right here at a point that is called the lesser or minor duodenal papilla. All right. And therefore, to recap, the main pancreatic duct of Hua-sung most usually, is going to combine with the common bile duct into forming a hepatopancreatic ampulla of Vatae. And the accessory pancreatic duct of Santorini usually is going to branch off from the main pancreatic duct, and it's going to open at a separate spot in the duodenum and the lesser duodenal papilla. All right, and so we have reached the end of our video today. Thank you very, very much for watching. If you have any questions, please leave it in the comments so that I may be able to help you address those questions. If you like this video, please click the like button so that I'm recognized by the YouTube algorithm. And if you find this video helpful and would like to keep up with more videos in the future, please click the subscribe button. My name is Khoa. Thank you very much once again. I hope to see you more in the next installments of Drawing to Learn Anatomy with Khoa. Bye-bye.